Welcome to Alexa Live. Alexa Live. She's always live, right, Steve?
She's always live. She's
Yeah.
always willing to be live.
So, this is the first talk in the multimodal track. My name is Arunjit Singh, if you want to be formal. And I'm a product manager on the Alexa multimodal team. Steve, why don't you introduce yourself?
I'm Steve Arkonovich. I am the developer of the Big Sky skill, and I'm going to be talking about how I integrated APL into Big Sky.
All right, cool. Let's get started. Gonna spend a few minutes on an agenda. We are going to talk about our multimodal vision for Alexa, what the term multimodal even means, because I know I didn't know what it meant when I joined this job, so I'm going to try and explain it the best I can. We're going to talk about Alexa Presentation Language. That's the new technology we introduced last year. Spend time understanding why it exists, what it does. We'll briefly look at an Hello World example, because every language has to have one. And then we'll look at a more real world example that comes from Steven's skill. Next, we'll look at adaptive rendering, because Alexa's in a whole bunch of devices, and we'll understand how your Alexa presentation language skill can reach all of those devices. And we'll also talk about Steve's been making money with APL.
I have. I'm excited to talk about that, always.
And finally, we'll take a look at some unique multimodal features that APL comes with. All right, you ready to get started?
I'm ready. Let's go.
All right. Okay, first, the journey. This is an interesting graphic that I saw the first time last year. And it kind of describes the journey of user interaction. We start out in the 1970s. Disco's all the rage. Capris are around, I think. I'm not around. But we've got character mode interfaces. We got keyboards, Unix System 5 Release 4, no Linux even. Things are going on. Next, it's graphical user interfaces with Macintoshes and Windows, drop-down menus, buttons, drag and drop, mice. All of that stuff shows up. Then you've got the web, which isn't a new user interface paradigm in so much as making GUIs portable, bringing them to people via browsers. And then mobile comes along in the 2000s with touch as a first-class citizen, glass screens, iPhones, Androids, all the rage. And then we've got voice interfaces, which is what we're talking about today. The reason this slide is interesting to me is because it shows how these interfaces accrete or build on top of each other. We're still using keyboards. Pull out your Android or iOS phone and bring up an editable text box, and you'll still see the same QWERTY keyboard that's attached to your laptop or desktop. Obviously, mice are still a thing, although many of us like to use trackpads, me included. The web's very much around, and mobile obviously is everywhere. So everything sort of builds on top of each other. Now, hold that thought in your head for a second as we talk about our multimodal vision, because this is what we were thinking. What would happen if we added a screen to an Alexa experience? Would it detract from the experience? Would we just turn Alexa into a user interface, into a voice interface that goes with a tablet? How would it actually work? So we tried that experiment in 2017 with the launch of the Echo Show and the Echo Spot device. What you see there is the second generation Echo Show, but in 2017, we launched the first generation one. We learned a bunch of stuff. So here's what we learned. Customers absolutely love having complementary visual content next to their Alexa experience, next to their voice first experience. Think about something like weather. You ask Alexa for the weather. She talks about what the temperature is right now, what it's going to be like tonight, and maybe gives you some idea of whether it's going to rain or not. But on multimodal devices like the Echo Show, and even on Fire TV, Alexa will put the forecast for the next few days on screen beside that, and maybe even give you information about precipitation, more detail than saying it's going to rain or not going to rain. And customers absolutely love this stuff because it's engagement, but it's ambient. It just shows up. If you're interested, you can look at that information. The other thing that we noticed was that adding visuals to Alexa voice forward experiences actually simplified interactions. Think about the restaurant skill, or rather the local search experience on Alexa, where You might ask Alexa for a list of Chinese restaurants, and she might speak out the top 3 to you on a speaker. But on a Echo Show device, she's going to put the top 5 or 10 results on screen. So next, a customer might say, Alexa, tell me more about the 5th one. Now that interaction would have been longer on a speaker-only device because the customer would have had to ask for the next 3 restaurants before they ask for details about the 5th one. And we found that a lot of customers just don't go that far. So multimodality, having another mode, a screen in this case, actually really helps the experience. The other kind of experience people enjoy are ambient experiences. You can see this on the home screen on Echo Show and Echo Spot devices, where customers see interesting information, news stories, or things they might want to engage in, and they're just presented there, but they don't have to interact with them. Similarly, inside of Skills and other Alexa experiences, we've got the concept of hints, where a skill might say, try saying, Alexa, tell me about sunrise. And you're effectively training your customer in what else they can do with your experience. And finally, there's rich media experiences like video, which kitchen domain, our kitchen first-party experience has taken advantage of. And Stephen also has started using in the Big Sky skill. So we saw that there were legs to this idea, that this idea had merit, and we doubled down on it. And today, Alexa as a multimodal experience is available not just on Echo Show and Echo Spot, but also on our range of TV devices, Fire TVs. In fact, there's the new Fire TV Cube, which was built explicitly with Alexa in mind. It comes with a far-field microphone. And of course, it shows up on tablets as well, Fire HD 8 and 10 tablets. We even built a special little dock that turns your Fire HD tablet into an Echo Show. So that's great. The multimodal experience reaches a bunch of places, but we also want to make sure that our developer community, that's you, has the tools to go out and build these experiences. And that's where Alexa presentation language comes in. So what does Alexa presentation language do? Well, it's like many other design languages, it is customizable. You can lay out your UI in any which way you want. This screenshot is from Stephen's Big Sky skill. And you can say it's pretty customized. There's very little limits, and you can bring your brand and bring your experience to Alexa. The other thing APL lets you do is adapt to different kinds of Alexa devices. We've got the Echo Spot with a tiny round screen. Obviously, information density on a device like this needs to be low because you can't actually present that much. So here's what Stephen's done on the Echo Spot, presenting one-word description of the weather, I suppose you'd say,
right.
and the temperature, right? Not much else, and basically flip through the different pieces of information using a slideshow. We'll see a demo of this in a moment. And the other thing we're doing is we're taking Alexa to all of these devices. Now, I talked about Fire TVs and Fire tablets and Echo Show and Echo Spot, but those are just the devices that Amazon makes. But we've got devices coming from our partners. For example, LG showed off their new line of TVs for 2019, all of which come with Alexa enabled, and they all support APL. We've also got this funky looking thing on the side here, the one with a pink motherboard. That's a reference hardware kit that you can actually go order online today. And when you get one of these, it comes with APL enabled. This is meant for device makers to prototype and build new devices. And then because multimodality, having a screen and touch and remote offers the opportunity to do new things, we've also invested in some experiences that are specific to multimodality.
Gouda, sharp cheddar, blue, brie, cheddar.
So that's Alexa just reading out a list of cheeses, because I like cheeses.
Yeah, my favorite cheese isn't on there. We have to fix that for the next time.
Which one's your favorite?
It's not there. We need to move on, but it's Manchego and it's not there. I think.
Okay, we're going to fix that.
Okay.
Next time there's Manchego on. I promise.
Okay.
Maybe I'll bring some. I don't know how the other people in the studio would feel about that. All right, so Big Sky with APL. Mr. Big Sky.
Yeah, so I'm going to talk a little bit about Big Sky and how I implemented APL on it. I think we have a video demo of Big Sky coming up.
Alexa, open Big Sky.
Currently, it's 50 degrees with clear skies, remaining that way for the
So
hour.
this is the basic
Tonight,
Big Sky
you can expect clear
APL
skies,
template.
turning to mostly cloudy skies by
It's actually going to
morning,
page
with
through a
another
couple
night low of
pieces of
46
information
degrees.
through an
Tomorrow,
APL feature
look
called a
for light
pager.
rain starting in the evening, with a high of 60. Would you like to hear more details?
So that's the Big Sky main weather template on Echo Show. And here's something I
Getting the radar
added,
data
which
for
is
the areas
live
around
radar
Redmond,
animation.
Washington. This might take a few seconds. Please hang on.
So there's the radar over Seattle on one of the very few days, evidently, there were no clouds in the sky. But I'm going to talk a bit about how I added live radar animation using APL in just a bit. So that's Big Sky on
You
the
can
Echo
say
Show.
Zoom in, zoom out, or quit.
Now we're going to move on to talk about some other features of APL. Oh, actually, I think I should show what Big Sky looks like on the Echo Spot. So this is a smaller experience, screen experience.
It's 48 degrees
And you
with
can
clear
see that the
skies,
visual language is
remaining that way
still
for the
similar,
hour. You can
but
expect
because of the
light rain
much
tomorrow
smaller
evening.
screen,
The high will be
I have to
57
spread out the
degrees and today's
information
low
that's
will be
presented
46.
across
Would you like
several
to hear more
screens
details?
in a slideshow. So we'll talk more about how I did this a bit later as well.
Okay.
Okay, yeah, so that's Big Sky with the new APL implementation. Arun's going to talk a little bit more about what an Echo Alexa skill looks like before we dive into the code.
Okay. So I know some of you are probably not familiar with how skills work, and some of you are. So I am going to do a really quick skill lifecycle 101 session where we'll talk about what happens when a customer says something to Alexa and it invokes a skill. So let's start out with what I said in that demo there, which was, I apologize, a little hard to hear. Alexa, ask Big Sky for the weather. So effectively, I'm asking Alexa to invoke Big Sky, that's the name of the skill, and ask the skill to bring up weather information. That goes into what we call Alexa service, which is what sits behind all of these devices. We do some speech recognition, that's the ASR box there. We run some natural language understanding models on that information, and then turn it into a series of intents and slots. Think of intents as the actions that Alexa wants the skill to take. So in this case, it might be get weather intent. Is that what it's called, Steve? Get weather?
Get weather, I think that's the main one, yeah.
Yeah, and slots are effectively arguments. So if I had said something like, Alexa, ask Big Sky for the weather in Seattle, there might have been a slot in there called City Seattle. All that goes to the skill Lambda, that is the thing in the orange circle over there. And the Lambda is just a piece of code. I like Node.js, Stephen likes Ruby. You can use whatever language you want. And that Lambda can then respond with speech, that's number 4 over there, and as well as an APL document using the render document directive, or APL commands, which we'll learn more about later. And those get sent down to the multimodal components in the Alexa service, and then eventually to the device. So part of what we do in the multimodal components is we turn the speech text that the skill supplied into speech, into audio. And that gets played back, and the UI gets rendered, and magic happens. So that's how a skill works. Don't worry, we'll look at some code in a little bit. So what is an APL? Well, like all design languages, we've got text, we've got images, lists, containers. Our containers are based on the Flexbox layout model, which is already part of CSS, for example. And of course, there's also a slideshow control, which we already saw working in Steve's experience. It's got styles. Styles can be inherited, they can be extended. We can do named resources, colors, dimensions, strings, and booleans. APL also has support for layouts. Layouts are composite components. So imagine putting together a container, a frame, a piece of text, and some graphics, and then sharing them throughout your experience, sharing them throughout your skill in different experiences. So that's what layouts enable you to do. You can package these layouts up, store them on S3, for example, as a JSON file, and then share them throughout your skill, or even share them with other people who might want access to them. Oops. And then we've got the when clause, which is a really powerful feature, which lets you conditionally show or hide elements on the screen, conditionally change the sizes of the things, conditionally do pretty much anything you want. So if you're familiar with CSS, it's kind of like CSS media queries. And then there's commands. Commands allow you to change whatever's displayed on screen. Imagine, like Steve, you've displayed some information on screen, and you want to move it around. You want to change the color on something. What you can do is you can send a series of commands to the device, and it'll change the visual composition on screen. All right, so how do you do a hello world with APL? Well, start by creating a basic APL document. Now, I'm quite proud of this slide because I managed to fit an entire APL document on screen.
An entire APL document, yeah.
It doesn't do much. It just says hello world.
It does enough.
Yeah, it does enough for now. Yeah, we're going to see a more complicated example a little later. But all it does is say hello world. APL is JSON. It is JavaScript object notification. Notification? Notation.
Notation.
Yes, misremembering. And it's pretty straightforward. We got a container. It's got a piece of text, and it says hello world. Next, you add your document to your skill. Because I'm a little lazy, I just stuck the document inside my skill, inside a folder called Demo1 Custom Template. I'm not very creative. You enable the interface APL in the Alexa Skills Kit console. It's pretty straightforward. It's just a toggle button that you can turn on. You can also turn it on in your skill manifest. You detect APL support at runtime in your skill Lambda. So you need to do this because the customer might be using a speaker style device which has no screen, so there is no APL. It's pretty straightforward. There's a supported interfaces collection that's part of the skill request, which you can inspect to find out whether the device supports APL. And finally, to render an APL document, alongside whatever speech you're supplying, you just add a new directive called Alexa Presentation APL Render Document and add your document in there. So that's hello world. That's straightforward, and it doesn't do much.
Right. So let's talk about something that does a little bit more. So Arun just told you how to implement a basic APL document into your skill. So now we're going to take a look at a real-world example and break down the radar template that I added to Big Sky. So when you create an APL document, probably you're going to start with a container. A container is just a native APL component, and as the name implies, it's there to contain and organize and arrange other APL components. So the Big Sky radar template begins with a container, and inside of which you can see a bunch of other visual elements. So what other kinds of visual elements? Well, there's a bunch of different APL components, and I think we could divide them into native components. That is the kinds of components that just come with APL, like video or images. So on the left-hand side of the screen, you can see the radar video running, and on top of that is a APL component called an image, which is overlaid on top of the video. APL also comes natively with a component called frames. Frames are really important for APL because unlike other APL components, frames can take background colors and transparencies. So you can use them to sort of divide up the visual landscape of the skill. The other kind of component that you can get in APL are custom components. So these aren't native. These are components that you have to define for yourself. So on the right-hand side of the screen, you can see a couple circular visual elements. I call them info circles. So those are custom components that I created and defined, and then I could use throughout the Big Sky skill. And in fact, I could use it across other skills if I wanted to. So with APL, you get a bunch of different kinds of components natively, and one of the most powerful features of APL, I think, is the ability to create, define your own custom components that really can make your skill stand out, look different from the rest of the pack, and set the experience apart from everybody else's skills. Okay, so that's what it looks like on the screen. Let's take a moment to dive into some of the code that created that visual experience. So we are going to go to the template.
Oh, let me help you with that.
Yeah, help me with that. It's Arun's computer. I can't figure out how to move it.
I'm just worried it might be stuck.
There we go.
Those
That's what
of
happens
you-
when you do things live.
Yeah,
You
I
just
know.
never know what's going to happen.
Live, Alexa live, everybody. Sorry.
Okay, so we're going to look at this custom template, and how we're going to do it is we're going to look at the document in the actual visual editor. So if you're coding an APL, you're going to make heavy use of something called the visual editor. Which will help you visualize and create the fantastic looking screens that APL allows you to do. So that's the APL document. Now we're going to bind some data to it. And
You
well,
might want to switch over to the Echo Show 2nd gen view. There you go.
well, for some reason the video component isn't actually videoing right now, but that's okay. What I wanted to show you in this is how to create the kind of screen that we just looked at in the overview. So let's just go to the document here. And as I said, the first thing that you're probably going to do when you create an APL document is create a container to organize and hold all of the other APL components that are going to make up the experience. So if you look at the APL code here, you can see that there is a container, and that's the main container that we saw. And you can see that underneath that container, inside that container, are all these other APL components, like here's an image type, here's a video type, more images, etc. So that's the basic setup for APL. You'll take a container, and then you'll import a bunch of other APL components to create the experience. And if we keep going down, we'll see these other components that I talked about, the custom components that I called info circles. There they are. And one thing to notice is that these custom components, use them just like you would use the native components, right? You just sort of declare the type, you add some parameters that you want to use, and voila, they show up in the APL document and on the APL screen. The only difference for the custom components is you have to define them yourself. So in an APL document, you do that in a section called layouts. So usually that's at the top of the document. There's the layout section right here. And you can see, you just say, look, here's my custom component. I want to call it an info circle. I want it to take these parameters. And then you begin building it up out of the other native APL components. So this is a little bit more complicated than the Hello World template.
A bit more complicated. Yeah.
A bit more complicated, but you can see it's pretty easy to get started with APL just by adding the native components and defining your own. Okay, so that's the Big Sky APL template. And now we're going to move on to talk about adaptive rendering, I think.
Yep. Okay. There we go. Found PowerPoint again.
Great.
Back to the world of slides. But we'll come back for demos. Okay, adaptive rendering. What are we talking about? Well, like I said, Alexa is finding herself on more and more devices now. We've got lots of speakers out there, but we're also starting to get smart screens on hubs. That would be devices like Echo Show, Echo Spot. And then we're also finding Alexa showing up on TVs, both ones made by Amazon, like the Fire TV, but also on LG TVs, for example. But we've got bigger ambitions. We also want to be inside cars. We've taken our first step with the Echo Auto product that you might have heard of. It doesn't have a screen, but we want to go there. and we want to be in appliances. We want to take Alexa wherever our customers are, and we want you to come with us. The problem is all of these devices have different kinds of screens. They have different widths, different heights, in some cases different shapes. Think about the Echo Spot with its round screen. So how do you make sure that the visuals you're putting beside your voice forward experience actually work on all of these devices? Well, there's two ways you can do that. Number one is you can inspect the viewport characteristics. These would be the pixel width and the pixel height, the DPI or dots per inch that a screen supports, the shape of the screen in your skill service or skill Lambda, and send different APL documents based on that, and even make Alexa say different things, different kinds of speech. Our SDKs in Python, in Java, and Node.js provide helper APIs that actually take this information and turn it into what we call viewport profiles. So imagine that something like an Echo Spot is what we call a small round hub, right? That's its viewport profile. So there might be another device out there with a small round hub profile, slightly different but similar enough that it's in the same profile. Whereas a TV would be a TV profile, and an Echo Show would be a hub landscape device, for example. So you can use this information to tailor your experience. And that's exactly what Steve does.
Yeah, right. So as Arun said, there's a couple ways that you could adapt the APLs across these different devices. And for...
Switch over for you. Yeah.
Great. And so for Big Sky, it has a lot of visual elements sort of backing up the voice-first experience. And it needs to send, in some cases, completely different APL templates to the different devices, just because the form factors vary so much. So as Arun said, the way you're going to do this, it takes two different steps. The first is to investigate, inspect the skill request. If anybody here has already written an Alexa skill, this skill request will look familiar to you. One thing that might not look familiar is the viewport object. So as Arun mentioned, this comes with every skill request, and it gives you just lots of information about the device that the user is invoking the skill on, for the shape, the size, etc. So you can inspect the skill request, see what kind of device is being used, and then in the actual skill itself, you would take that information and send out a different APL document depending on the viewport characteristics. I don't actually use the SDK, but I can see that it's actually super helpful because, as Arun said, it comes with some helper methods, some convenience methods that let you categorize all those different viewport characteristics into convenient packages and then send out different APL documents depending on the device characteristics. So that's the first way that you can adapt APL for use across different kinds of devices. The second way that you can adapt APL is not within the skill Lambda, but within the APL document itself. And this is done through the use of when clauses, and when clauses allow you to conditionally render or not render different APL components or arrange the APL components different ways on the screen, etc. So in Big Sky, I use both of these strategies. When I'm not so much interested in sending a completely different visual experience to different devices, but rather modifying a particular APL document, I adapt in the APL document itself. So what does this look like? So I think it's best actually to show this on the visual editor and see how a when clause can actually affect what the user sees on the screen. Okay, so that's the basic APL document. We're going to need to bind some data to that to make it appear reasonable. Okay, so there is a Big Sky template for weather at a particular hour. And the thing to notice, which should be familiar to you, is that these info circles, which we talked about, and there they are declared in the APL. Now, one thing that is different from when you saw it before, there's the info circle, the various parameters it takes, is the when clause at the top, which is bound to some of the data in the data JSON. And the when clause basically says, look, if there's any chance of precipitation, then show a circle that shows the chance of precipitation. On the other hand, it takes up a lot of screen space if you're living in Arizona and it's never raining, and I don't need to show that information. So if you look at the precipitation probability in the data, it's 30%. But if we changed it to 0, using adaptive rendering and the when clause, you can see that the APL document automatically changes, right? So it's not a matter of like sending out different documents. It's a matter of adjusting the document at runtime depending on the weather conditions that are occurring right at that time. So those are two really different and powerful ways that APL can be adapted across devices or even in a device depending on whatever conditions you want it to be responding to.
All right. Thank you.
Yeah.
It does rain in Arizona.
Yeah, I guess it does.
I went there in August once, and there was a monsoon. I saw the most wonderful lightning strikes in Arizona I've ever seen, because it's flat and it's desert. It's beautiful. Anyway, enough about Arizona. Arizona presentation language now.
Right.
Alexa presentation language. All right. So we've seen how to adapt in the APL document. We've seen how to adapt in the scale lambda. I also want to talk about adapting for another thing, which is touch or inputs in general. Like I said, Alexa's on Echo Spot and Echo Show style devices. And one of the things that these devices have is touchscreens. So you want to be able to respond to customers touching the screen. In addition, there's also TV style devices, which usually come with some sort of remote that has a little directional pad or D-pad that customers can use to select things and move the cursor up and down. Our solution to that problem is an APL component called Touch Wrapper. And this thing is, it looks simple, but it's really, really powerful. What you do with Touch Wrapper is that you wrap other APL components, hence the name, Touch Wrapper. Yeah, it doesn't wrap. Wrap?
It doesn't wrap.
I just remembered MC Hammer is not a touch wrapper.
No.
Okay. Anyway, so touch wrapper can wrap any APL component, and what we're doing over here is we're attaching an on-press handler to the touch wrapper and sending an event up to the scale lambda with some arguments. One of the arguments is a literal, it's just next item. The other argument is a data binding expression. Now, whenever you see a dollar curly braces expression in APL, and Steve had some in his document as well, that's basically going out to a data source and binding to the data source. And this is a really powerful feature of APL, wherein you can send a data source alongside your APL document, and depending upon the values in the data source, the document can present whatever you want and even modify itself, as it did with the precipitation example that we just saw with Steven's template. So once a customer either touches the control that the touch wrapper is wrapping or uses their remote to select something, here's what happens next. Your skill gets what we call a user event, and that comes with the arguments that the touch wrapper sent up. As you can see, next item is there, and the data binding expression has been evaluated and resulted in business relevant identifier. Did I say I wasn't very creative? I'm not very creative. So going back to that example of what a scale flow looks like, well, here we go. You touch a touch wrapper in this case, and all of the same things happen. The only difference in this case is the touching a touch wrapper and the skill getting a user event. It can still respond with voice, with another APL document, with whatever you want. All right, next, we're going to see how Steve made money with APL.
Yeah, okay, good. This is my favorite part of this presentation.
Okay.
So Yeah, so when APL came out and I integrated it into Big Sky, I knew that one of the things I really wanted to do was provide live radar animation. People have been asking for it. They've been emailing me. There's like requests on Reddit. So when APL was there, I thought, this is great. I can just add live radar animation. And we saw how just incredibly easy it is. It's trivial in a way, just to add video to your documents with APL, to your skills. Couple lines of code, you're done. So APL made that part super easy. The difficulty was actually getting the information to display. I needed fast, reliable, dependable, worldwide radar imagery, which existed, but it actually cost me a little bit of money to access. So I thought, well, APL could provide this great experience for the customer. With ISPs, I could give the way a customer to access it and a way for me to provide it for them. So ISPs, in-skill purchasing, and APL, Alexa Presentation Language, I think they really are a great fit together.
Now, you have some code to show us, right?
I have some code. I have some code to show you. Let me show you some code. Okay, so how do you do this? How do you combine in-skill purchasing and Alexa Presentation Language? It's actually pretty straightforward. I mean, building in-skill purchasing into your Alexa skill from scratch is probably beyond what we have time to do. But the overall logic is pretty easy. The first thing you're going to do is take a look at the skill request and make sure, if you're trying to provide some APL, that the customer is using a device that actually will show, in my case, live radar animation. So I think we saw this a little bit before. You'll need some piece of your code that will inspect the skill request to see, look, is the user using a device with a screen so they actually can see the animation. Suppose that they are. Well, then the next step is to have some piece of your code that would check whether they've already purchased the premium experience or entitled to purchase it. So in this code here, we have an entitled products check. Amazon makes this super easy. They have an API and in-skill purchasing services. You just say, you give it some information, and it tells you whether or not the customer has actually purchased the premium experience. Okay, so those are the two things you need to know. Can the user view the APL, and are they entitled to view the APL? And if they have satisfied both of those conditions, you simply send the relevant APL document to them. And again, you can use some adaptive rendering to decide what APL document you want to send to them. So it's a really natural combination, I think, Alexa Presentation Language and in-skill purchasing, just because they're easy to combine, and APL gives you ways to provide a lot of information and a lot of great experience to the customer, which they can access through in-skill purchasing. So I think it's really great. It's worked out well for Big Sky.
Cool.
Yeah.
Steve, what's your upsell strategy? What do you do to try and get people to make the in-skill purchase?
Yeah, so I mean, if we went back through the code and you ask whether you query the Amazon API, like, does the customer already have access to the premium experience? If the customer says, if the API comes back and says no, they don't yet aren't entitled to this, then that's a great time to send a short upsell message to them, informing them about what they could get if they just if they use ISPs and skill purchasing. And then that is super low touch, low friction. That's done in a few seconds, and then you can just send along the APL document.
Cool.
Mm-hmm.
All right, great. All right, one last time in the slide land. All right, there we go. All right, so let's talk about some unique multimodal features that APL allows us to enable. Most of these features are enabled by something we call APL commands. Commands are simple. You've sent down an APL document, it's on screen right now, and you want to do something to change the experience. For example, you might want to kick off a slideshow, start a video playing, or have Alexa highlight something on screen. the way commands work are, as we saw initially, a skill is able to respond with speech or with an APL document using the render document directive. Well, to respond with a command, all you need to do is respond with an execute commands directive. And commands can do a bunch of stuff. Here's one example. This is the Food Network skill, this TV channel, and they built this experience where the skill will actually read out information about different ingredients. Keep an eye on the blue highlighted line there. Now, we've turned off the audio so I can talk over it, but Alexa's actually speaking out that text as she scrolls it. And the speak item command, I think you use it as well, Steve.
I do.
It's about 5 lines of code, I want to say.
Yeah.
So it's super easy to add. It's really straightforward to add something like this and make your skill way more interactive. We've also got speak list command, which was the thing powering the list of cheeses that you saw earlier. We are clearly missing some very important cheeses. We'll fix that. And then there's the auto page command, which basically, again, Stephen uses in his experience, lets you run a slideshow. It's pretty straightforward, but also very powerful. You can run timed slideshows like the one here, where a slide flips every 3 seconds, or you can use a bunch of set page commands to custom run a slideshow. So imagine a slideshow that responds to customers' voice input, Alexa next, Alexa previous, whatever they want to say. We've also got other commands to control media, which is video, scroll up and down, side to side. And also, we've got this feature called parallel and sequential commands, which are effectively meta commands that let you combine commands to do some very, very interesting things. Have things run one after the other in parallel to each other. You get the picture. OK, so when I watch one of these talks or go to one of these conferences, one of the things I like to ask myself is, if my boss asked me what I did, or if I were my own boss, what do I take away from a talk like this? So I just put that in a slide. Well, you should tell your boss. Well, there's a big opportunity here. Alexa's going multimodal, voice-forward experiences with screens. And it allows for some pretty unique things, like the radar scenario that Stephen built. And there's tens of millions of Alexa multimodal devices today. It's easy to think of Echo Show and Echo Spot as the only ones, but that's not true anymore, because we've got Fire TVs, we've got Fire tablets, and we've got third-party devices like LG TVs coming out. And APL gives you the tool to use these screens, to use the remote controls, to use the touch screens, and also adapt to these different devices. All right, that's it from us. We've got a survey. My Twitter handle is up there. Stephen, how do people reach you?
They can reach me through Facebook. They can reach me through email, and they can reach me on Twitch, because I think we're going to a Twitch feed right after this to be answering questions and talking more about APL and maybe some in-skill purchasing too.
All right, that's cool. That's it.
Thank you.
Thank you.